Welcome back. It's getting on towards late summer here. It's been a nice season. Things are growing well, and as usual, we could really use some rain. Unfortunately, fascism is continuing to consolidate power in this country. Just a couple weeks ago, Johann Sebastian Guerrero was murdered by an ICE agent not far from here in Biddeford, Maine. There has been no justice for him or his family, and ICE continues to operate as a rogue paramilitary force, inflicting violence as they see fit with essentially no oversight. I encourage everyone to be involved in some way in the struggle for a better world. While it might seem pretty bleak at times, and I fully expect most things to get worse before they get better, giving up or ignoring the current situation is not a viable option. For more organized thoughts on the current state of politics, you might try fellow Channel Zero podcasts, The Dugout and The Beautiful Idea. I also want to thank MK from the podcast The Child and Its Enemies for having me on as a guest. I'll link to that episode in the show notes so you can find it easily. Okay, that is enough of that. Let's get back to plants. But first, here's a jingle from another podcast on the Channel Zero network.
Hello and welcome to The Child and Its Enemies, a podcast about queer and neurodivergent kids living out anarchy and youth liberation. Here at The Child and Its Enemies, we believe that youth autonomy is not only crucial to queer and trans liberation, but to anarchy itself. Governance is inherently based on projecting linear narratives of time and development and gender onto our necessarily asynchronous and atemporal queer lives. And youth and teens are at the center of this form of oppression. Our goal with the podcast is to create a space by and for youth that challenges all forms of control and inspires us to create queer, feral, ageless networks of care. I'm your host, MK Zariel. I'm 15 years old, and I'm the youth correspondent at the Anarchist Review of Books, author of Debate Me Bro, and organizer of some all-ages queer spaces in my city and online. If you want to learn more or join us on Discord and Signal, our website is thechildanditsenemies.noblogs.org.
Welcome to Propaganda by the Seed. If you could both introduce yourselves, I think that would be a great place to start.
Sure. Swathi, you want to go first?
Sure. My name is Swathi Nadakuduti. I'm an assistant professor in horticulture sciences department at University of Florida. And my lab, we study medicinal plants. Our research program is centered around chemicals that plants make that can be used for pharmaceutical or agricultural applications. We mostly study the genetic aspects of plants and how they influence the chemistry eventually. So thanks for having me.
Yeah, thanks for being here. That sounds like fascinating work.
Thank you.
Yeah, and I'm Chris McCurdy. I am a professor of medicinal chemistry in the College of Pharmacy at the University of Florida. And we work very closely with Swathi and her team because of the work that she described really helps us understand the work that we're doing, which is looking really at the ethnopharmacology of certain medicinal plants and understanding how those plants are used in their native cultures, but also understanding the chemical profiles inside those plants and what the pharmacologies are that are related to them. And partnering up with Dr. Nadakuduti is wonderful because we can actually start to understand what parts of the plants are producing these chemicals, how the plant is producing these chemicals, and is there any opportunity there for us to, sort of influence the plant in the way that it's producing molecules based on the pharmacologies that we're learning about the different chemistries in that plant. And so it's really a neat partnership when you are able to do those types of things. And then that's what we do together. But we also have in my lab a pretty extensive network of pharmacology collaborators. So we work with mostly animal models, rodent models of pharmacological behavior to understand how these plants are actually behaving and producing their effects, what's beneficial potentially, and then where harmful effects or side effects might come into play from those studies as well. So that's a very 30,000-foot overview of sort of how we all work together, and look forward to getting into some more specifics. So.
Yeah, awesome. Hearing a little bit more about your background than I knew, I'm even more excited for this interview. I think there's a lot of knowledge in this Zoom room that just isn't out there in the public, or it's in academic papers probably. But yeah, I'm excited to bring some of that to a more lay audience. So I guess let's start with what is kratom or kratom, and where does this species come from? And also, what is the proper pronunciation of that word?
I think you pronounced them both correctly. There's the general consensus in Southeast Asia, particularly in Thailand, is that it's called Kratom. In Malaysia, it's shortened up to Kitom, or Biak, or Biak Biak. And those are sort of the traditional ways of pronouncing it. We always called it kratom in our work because we were shortening the kratom pronunciation. But as it started to pick up and become culturally more popular in the Western world, kratom has certainly become sort of the street known name, representative of the products that are available in the marketplace. So you may hear us bounce around and refer to it in many different ways, but for the most part, we try to stick to the traditional aspect and call it kratom. But what is it, right? So it is a tree, and Dr. Nadakuduti could discuss this much better than I can. But I'll just say what it's been used for culturally, and she can come back to the more plant-based information. So culturally, it's been used in Southeast Asia, and in particular in Malaysia and Thailand for centuries, for its ability to increase stamina, increase endurance, decrease pain, and increase tolerance to the tropical environment of the most often the consumers or outdoor laborers in that region. And so they'll use it quite regularly. They either chew the leaf in Thailand or they consume a decoction. They make a tea, but it's not like a tea we would steep with tea leaves in a few minutes. They spend hours boiling these leaves to create a very concentrated aqueous decoction of material that's very clear when it's consumed warm, but actually starts to precipitate and turns cloudy when it's cooled to even ambient temperature, which could be in the 90s easily at any given time of year in that region. So it's usually then mixed again with warm water so that it can be consumed as a clear liquid. But they use it that way. They use it primarily for this sort of stimulant-like effect, this sort of, again, endurance, mood enhancing, if you will, effect for the daytime. And they'll consume it as they're working throughout the day, generally stop in early afternoon, very similar to how we would consume coffee or tea in the Western world for the energizing effects, and then we know that it can interfere with our sleep. So we don't take coffee generally in the evenings. There are some people that can do it, and kudos to them. Not me, I'm too old for that now. But certainly there is a place though for kratom use in the evenings, and that was usually around the weekends or social gatherings where it was used to sort of decrease social anxiety, increase discussions, sort of let down your guard, if you will, social lubricant type usage, where people could get sort of a sedative like or somewhat euphoric like feeling by increasing their consumption amounts. And so there's been this paradoxical discussion about it being sort of a stimulant like effect at lower doses and lower consumption amounts versus a higher consumption amount that produces what's been referred to oftentimes as an opioid like effect. But what we're learning is not really opioid at all. It's more of a sedative, relaxant, calming effect associated with other systems in our body, but certainly opioids are at play all throughout this as well. And I'm sure we'll get into that in more detail. But I'll turn it over to Swathi just to talk a little bit more about the specifics of what we're dealing with in terms of technical.
I
Awesome.
would say Dr. McCurdy had traveled to the native, regions and has experienced firsthand. And I would take his word for it, because what I've been dealing with is plants in a greenhouse that we grow that we got from different sources, which is still great. But I'd like to sometime travel and learn more how in the native regions it's being cultivated and consumed. But I agree, everything 100% what what we heard from Dr. McCurdy,
Yeah,
Cool.
I guess if we, technically it's I don't know if you want to talk about the genus and the species a little bit,
Right.
the
Yeah.
different amounts of species that are present.
Yeah.
That's really your
Absolutely.
wheelhouse. So
Yeah, that's a good point. So, obviously everybody's interest is kratom, which is Mitragyna speciosa, right? But in my lab, we don't limit ourselves to just Mitragyna speciosa, mainly because when we started with kratom, right, we started collecting different varieties of kratom plants from different sources. Especially Dr. Pearson, who used to be working at UF, recently moved, but he gave some plants of kratom I got from other sources. And when we saw those plants, not only did they have some morphological differences as we grew them in the greenhouse altogether, but when we analyzed their chemistry with Dr. McCurdy's lab, we saw that there's variation in chemical profile. And what we saw was some kratom varieties actually made very low amounts of mitragynine, whereas some made very high amounts of mitragynine. And we never tossed any plants. When we saw that variation, we started to think how interesting this is, that they're all speciosa kratom, but they have different chemistry. And so we started to do DNA barcoding. So basically, DNA barcoding means you use a specific region of a DNA that's kind of conserved, and we try to separate any species, different species of the same genus Mitragyna, or sometimes we can even differentiate varieties within the species using the DNA barcoding. So we started to DNA barcode the plants we have, and we did a kind of phylogenetic analysis, we call it, which is nothing but comparing at the DNA level and organizing them. And we found that certain plants with high mitragynine group together and others with low group together. And when we looked at the DNA barcode, they had sequences of Mitragyna speciosa in their code, but also other species such as Mitragyna hirsuta parvifolia. And it was very interesting. So when we saw that certain varieties of kratom had both alleles of two different parents, which could be kratom as one parent and other species. We suggested that it could be possible crossing between kratom and other species, right? And so and the chemistry also matched with other species. So we expanded our study because our goal is to study how genetics of a plant is impacting the chemistry. And so we kept expanding our germplasm to collect interesting varieties. And now we can say we are able to predict by DNA barcoding, if you give me a leaf, whether it will have high mitragynine or not.
Fascinating. Um,
Yeah.
is mitragynine the sort of most active constituent in kratom, or are there other alkaloids that are also like pharmacologically active?
Yeah, I think it's a great question, and it's a question that is sort of clouded in confusion now because when the older studies that appeared in the literature, and I speak of almost all the way back to the early papers in the literature from the 1960s and 50s describing some of this, the major alkaloid in Mitragynous speciosa is mitragynine. And oftentimes, when we find a major alkaloid within a plant, we believe that all of the pharmacological activity, or the majority of that pharmacological activity, is going to be because of that, most abundant compound, and that makes logical sense. In the case of mitragynine, that was the dogma that's been carried pretty much all the way till today. And in fact, we use mitragynine as a sort of surrogate marker for kratom or exposure or use in blood tests or drug tests. They don't look for any other alkaloids that are in there. And then a lot of the literature also discussed the fact that 7-hydroxymitragynine, which is a very minor, if not even an alkaloid that exists in the leaf material naturally, or I should say, that the plant actually synthesizes. Um, it's present in very, very small amounts, but it was known to be active as well pharmacologically. And so for many papers that you can even read today, they'll talk about mitragynine and 7-hydroxymitragynine as being the major active alkaloids in the plant. But a lot of the work that we were funded to do from the National Institute on Drug Abuse was really to go beyond just those two molecules and understand what are the other, prevalent compounds that are present in this plant. What are the other alkaloids that could be of pharmacological importance? And we were some of the first to publish big studies looking at hundreds of drug targets and where these alkaloids interacted, and came to realize that yes, mitragynine is the most prevalent in Mitragynous speciosa in most of the cases, but it may not be the most interesting alkaloid, the most pharmacologically active alkaloid within the plant. And we came to find out that it does interact with opioid receptors, which has been the long-standing history of this plant as well. But we also learned it interacted with serotonin receptors, and serotonin is intimately involved in our mood. Many of the antidepressants and antipsychotic drugs are directly targeted to the serotonin system to elevate our mood. And so understanding that there was pharmacology associated with serotonin receptors sort of map back onto that traditional use of that mood elevation, that sort of, good feeling overall effect. And then we learned that it interacted with adrenergic receptors as well. And the adrenergic receptors are really the target for epinephrine or adrenaline. And that is a stimulant. That's what gives you your sort of fight or flight response in the situation, and can give you that stimulant-like effect, that increased stamina, that sort of desire to continue working in worse conditions that could be prevalent, and then you get the benefit of a little bit of opioid activity to sort of maybe knock out some of the pain. But what we've learned over the years is that all of these systems are actually involved in pain processing. And so the plant itself has a unique sort of pharmacological shotgun. I call it a complex symphony orchestra or a pharmacological shotgun approach of being able to target many systems in our body, which I think from a um, medicine standpoint is really fascinating because we don't have drugs in the prescription drug market that target these systems all together at once. And we don't traditionally think of treating pain with, excuse me, drugs that can affect these other systems, which may, counteract some of the problems that we see with traditional opioid drugs that are prescribed, that are depressants that make you, kind of detached, not want to be involved, not want to get up off the couch or out of the bed. Whereas, approaching it with the natural sort of pharmacology that this plant has given us, it's really an interesting find. And so there are compounds that are highly specific that interact with the serotonin system. There's compounds that highly specifically interact with the adrenergic system. And as you can imagine, there's compounds that interact more selectively or specifically with the opioid system as well. But to some extent, it's almost like a soundboard of music. And you can think of each lever on the soundboard as one of those systems. And so one compound may have a high amount of serotonin activity and a medium amount of opioid activity and a very little bit of adrenergic activity. But you can play that soundboard with each of these compounds a little bit differently. And to me, that's been really one of the most fascinating finds. And we're still trying to understand what are the contributions of these additional alkaloids. So as I said, mitragynine makes up the major amount. That's followed by, in the marketplace now, speciosiliatine, which used to be a very minor and low occurring alkaloid in the plants. And really, Swathi was the one that uncovered the reasoning that we've seen this sort of change in the balance of alkaloid in the marketplace, or at least why we have a hypothesis that's happened. And then you have painanthine and speciogynin, which are two other alkaloids that interact heavily with serotonin receptors. The two of those together make up a significant amount of the total alkaloid content, and they're basically like the same molecule. There's one small difference in them. It's a carbon-carbon double bond that gets reduced in painanthine to speciogynin, and so it's kind of like having a key that unlocks the same door, but one does it just a little bit more fluid than the other one, but they both work in the same exact way. So that double bond shortens the carbon-carbon bond length just a slight amount, slight enough that it changes a little bit about how the compound is handled by our body, but not enough that it changes how it's pharmacologically working in our system. So it's pretty interesting that you have mitragynine, which seems to hit all of these targets, not very well at all, but we still consider it to be the sort of major player in the pharmacology. I think as we start to learn more and start to understand what the contributions are of these other compounds, we'll understand that it's much more complex than just mitragynine or the 7-hydroxymitragynine. And I think, working with Swathi's team and really being able to talk to traditional users of how they handle the fresh leaf material, what leaves they actually use off of the tree versus which leaves they avoid using off of the tree, really spawned some studies that Dr. Nadakuduti's team did that really led to some fascinating answers and these sort of hypotheses of why we think the alkaloid contents have shifted in the marketplace. And so that's a good segue to just kind of throw it back to her.
Yeah, first fascinating thing to me is how pharmacy team has separated these such similar looking alkaloids. It's already amazing to see how they've separated these stereoisomers, which are so identical. It's just difference in one carbon position. But our lab, when we started, collecting these different kratom varieties, as I said, we did chemistry on them, and some of them actually have higher speciogynin and very, very small amounts of mitragynine. And their barcode had told us that they're not pure speciosa. They have some sort of hybridization or crossing probably happening with other mitragyna species. And so we collected other species as well. Right now we have parvifolia, we have mitragyna hirsuta, to just answer some of these questions. But other thing we found when we did the alkaloid chemistry, so first we wanted to test the targeted alkaloid chemistry from different parts of the plant. Question being, do only leaves make them, or do stipules, stems, and other roots and every other part, do any other parts make these alkaloids? And so we did analyze different parts of the leaves, stipules, and all of these different parts of kratom. And we found that stipules, which are these leaf-like appendages under the leaves, they also make the same, almost a similar profile as the leaves. So we don't need to throw them. I mean, we could use them as well. But then stems, roots have very little alkaloids or no mitragynine at all. So it was a good negative control for us if you want to study gene expression and so on. But then when we did leaf chemistry specifically, what my student, my PhD student first did was to collect all the leaves in a plant as one replication, and we had multiple replications, and we saw the data was all over the place, so variable. And then we said, hey, this leaf data doesn't look, consistent. So we decided maybe we are pooling all the leaf developmental stages, young, mature, all sorts of leaves together. So let's separate and define each leaf stage and collect them separately. So we kind of defined a leaf based on the diameter, less than 4 centimeters, 4 centimeters, 7 centimeters, and so on. And then we collected medium size and large, which are more mature, directly coming. So we kind of defined every leaf stage. And then we did a separate chemistry on them to see if there's any variation. That's when we found that some of the metabolites that Chris had mentioned, especially speciociliatin, that was pretty high in young leaves only, and it reduces in amount as the leaf matures, but mature leaves have high mitragynine. So there is a significant variation in the alkaloid profile as the leaf develops, which is a very important aspect to know, because we can study how these molecules are made based on that, and we can hypothesize which genes are expressed in that stage versus mature, which chemicals are expressed in young versus mature. So that was one thing that was important, that we found the young leaves had high speciociliatin, whereas mature leaves had high mitragynine in
That's
our study.
fascinating.
Right.
Do we think that these alkaloids are primarily there to prevent herbivory, and maybe there's different insects or animals or whatever that are attacking different leaf stages, so the alkaloids kind of need to shift as the leaf matures?
Absolutely. So mainly alkaloid compounds, we call them as plant specialized metabolites. There are different classes of plant specialized metabolites, meaning plants make different chemicals, right? We call them metabolome. But primary metabolites are the ones like lipids, carbohydrates, all of these that are necessary for plant survival, all of them, in all plants, they're conserved. But specialized metabolites are unique to certain plants. Only certain group of plants or make them for defense purposes, mostly for defense from biotic, abiotic stressors. And plants make alkaloids mostly for defense against biotic stresses. So alkaloids are these bitter compounds, nitrogen-containing bitter compounds that prevent herbivory or other pest and pathogen attack. And they are toxic too. And several poisonous compounds belong to this class of plant specialized metabolites from other families. But rubiaceae, like caffeine and coffee also belongs to the same family as kratom. So these alkaloids are mainly for defense purposes, and probably the plant is dealing with different types of pressures at different ages of its development. And so there could be, but we don't know at this point. We have initiated experiments, which is exciting, to study the kratom extract against certain agricultural pests and pathogens with pathology department and also with other university collaborations. So that's exciting. So mainly these are defense related compounds, but we don't know which particular compound is useful against what type of pest or pathogen at this point.
Cool. Well, it sounds like you're doing many different studies and probably have a lifetime's worth of work ahead of you.
I hope so,
Um,
yeah.
So how are these trees grown in the tropics, and can they reasonably be grown in containers in temperate climates?
Yeah, so obviously I didn't travel to Southeast Asia, but based on literature and based on what I've heard from people in the Kratom conferences and seen a lot of pictures that, most in Southeast Asia, it's cultivated outdoors, right? And field cultivation. However, in Florida, I mean, obviously we have variable hardiness, USDA plant hardiness zones, right? And I think that this plant can survive tropical climate, mostly, I would say 10B to 11B. But anything, it cannot tolerate frost. So in Gainesville, we have not planted them in the ground. We've mostly grown them in containers and put them in greenhouses with sort of standardized temperature conditions so that they don't go below that. And so they do pretty well. I can tell you, we have forests. Sometimes you have to prune them and harvest a lot of leaves and prune. They do pretty good, but mostly the cultivation in Southeast Asia is outdoor field cultivation.
Yeah,
Yeah.
and I can add to that just from being there. There's a couple different ways that the different farmers will grow. One is that they just let the trees grow like they would normally grow, and they build scaffolding around those trees to harvest the leaves. So they'll climb the scaffolding. Other farmers have gotten a little smarter, I think, in cutting those trees down every year to a certain, like 2 meters height. And so it does two things. It stops the growth from going, sort of straight up or lateral, and it makes the plant spread more horizontally. And so the bushes, they look more like bushes than they do trees. But it also increases the biomass quite significantly, because the trees are trying to attract as much sunlight with their leaves, their solar panels, right? They're trying to capture as much energy as they can. And so if they're not able to get closer to the sun in a vertical way, they put out as much growth horizontally. And so it's very interesting to see the two different ways that it was cultivated outdoors there, and the sort of arguments for why they do it one way or the other.
That's a good point. We prune our trees also, meaning when you have an apical meristem, it's called, like the stem cells at the top of the, when you remove that, all the axillary meristems get activated and you see more branching. Instead of a single trunk, you see more branching. And we do that in our greenhouses mainly because we want to get more cuttings for our propagation, more leaf material, and so on. So we also prune to keep them, and also we can't handle such large trees, and so we prune them. We prune them heavily every year to get a lot more branches. And sometimes it's too horizontal. They're like too horizontal if you cut too low. So we kind of maintain a certain height and prune them. Yeah.
Cool. What have you found is the best propagation technique for this species?
Yeah. So two main ways of propagation. One is by seed. If you have source for viable seed, most of the seed that we received from different people was not viable. We failed to germinate it most times until we got seed, from Thailand, and it was viable. I believe that the seeds, I don't know how long they could stay viable in a refrigerator, but we store them at 4 degree. They're pretty fine since we received. It's like a couple years. They are still germinating. But the seeds prior to that we received never germinated. And we don't know how they were stored or when they were collected, from what sources and so on. But if you get viable seed, there is a ton of seed in one pod and you get so many plants, but that's a slow process. And also, there could be variability between the little plants because of the segregation and genetic segregation that can happen. Whereas most of our propagation is by stem cuttings. When we prune our big trees in the greenhouse, we take a lot of cuttings from them, like little pieces of stem, and then we dip them in rooting hormone, and we root them. So this is faster, and also it maintains somewhat of a maturity from the mother plant. So and the plants are all clones, right? If you're taking from one plant, all the cuttings are identical. They're clones from the mother. So we could make good, they could be like a we could take all of those as replications to compare without variation.
Very cool.
Mhm.
Do young plants have less alkaloid content, or do they come up to alkaloid production pretty quickly?
We have only analyzed different leaf development stages from a single plant, so that we know if young leaves versus mature leaves are coming from the same plant, because sometimes you don't know the age of a cutting. You can't tell the age of the cutting unless it's coming from a seed propagated plant. You can't tell. Most of our plants are cuttings because we receive from different sources. We just propagate by cutting. So I can tell you that young leaves versus mature leaves, the alkaloid content per se is not low in young leaves. In fact, what we found is the total in the crude extract, the alkaloids are higher than in mature. It's just the mitragynine is higher in mature leaves, but the total alkaloid content is not. Young leaves have higher other alkaloids, such as speciosiliatin, corinanthidine. They're higher in young leaves, but the total alkaloid content is also higher. But mature leaves have more mitragynine, alkaloid content is not less in young leaves.
Yeah,
Fascinating.
and I think it extends even to the young plants. The only reason I can say this is we did do a little bit of seed cultivation when Dr. Pearson was here, and we saw the full suite of alkaloids even in the young emerging plants. So we think that all the machinery and all the content is there, that there's no need to wait a certain amount of time. But it was a question that was burning in my brain when I went first to Malaysia, and I asked them specifically because they have various stages of tree age. At what age do they start to use trees? And they say between 3 to 5 years is when they'll really start to get the full profile of. They're not doing the chemistry, but they're doing sensory, right? So they expect a certain flavor profile, a certain mouthfeel, and then a certain pharmacology that's associated with that. But they're not paying attention to what compounds are responsible for that. They're going by the sort of, this is the way it's always been, this is the way we do it. and whatnot. And I found it to be very interesting because to me it very much paralleled how the wine industry works with grapevines. So you can get grapes produced right away from grapevines, but the quality of those grapes is not something that someone would say, oh, we're going to make a single vineyard Chardonnay from this in its first year of existence. From speaking to grape growers, they say it's in that same ballpark. It's really 3 years that you can start getting good quality grapes to make wine with, and then it's another 2 or 3 more years before you could really get single vineyard quality. And so just speaking on sensory levels, I think that's really where the differences have come about in our learning process. And we haven't, I think the other key point to state here is we're only looking at alkaloids right now, and alkaloids are not the only chemicals present in the plant. It's the when alkaloids are present, we always think that they're the ones responsible for the pharmacologies, but we have many examples of other classes of chemicals that don't contain nitrogens that are very important biological and biologically active compounds. Cannabis, pretty much has all cannabinoids that have no nitrogen containing atoms in their structures. And so yeah, it really is something that has been somewhat neglected to this point in the research space. And that's really looking in some of these other chemical classes that could be present that might be responsible for some of those flavor profiles, might be responsible, for some of the mouth feeling or whatever that the fresh leaf, traditional use is really going for. Dried leaf material that's here on the market in the U.S., it's not consumed the same way that it's consumed in Southeast Asia, and so for those nuances to be present, we just don't have that in our space.
Circling back a little bit, we've heard from you a lot of very interesting info about how it's used in Southeast Asia. Could you describe how people are using it in the US and how that's different?
Yeah, so I mean, like I said, the use in Southeast Asia is sort of all fresh leaf. There are some dried products and extract products that have made it into the marketplace in Southeast Asia now because of their sort of abundance in the Western world, and that transfer. But those leaves are dried and then ground. They used to be crushed. Some materials coming into the US are still crushed leaf, but they're dried. And then you have very finely ground powder that's coming in. And it's easier, obviously, it's easier to package those. You can get more material. The finer you grind it, the more you can pack and ship. And then that material is coming over to the US, or it's going to other countries to be processed and extracted and then shipped into the US to be manufactured into products. So there's various stopping points along the way. We're learning it's not just a straight shipment out of Southeast Asia to the US. There is still that going on, but there are some other intermediate processing going on in other countries such as India and China that we're aware of. But the use in the United States and pretty much in the Western world, I would put Europe into this category as well, is really of these dried leaf products. Interestingly, the alkaloid chemistry stays consistent between the fresh leaf and the dried leaf. You do over time, you start to see a decomposition of compounds or a disappearance of the alkaloids, but it's not at a significantly fast rate. But we do start to see oxidative products that are formed. So post-harvest artifacts or byproducts that can be formed. as these leaves dry and as they age. One of those is 7-hydroxymitragynine. That's been long thought to be one of the important pharmacologically active compounds. We found it in very low trace levels in freshly harvested leaves. And I've always been under the belief that it's because as soon as that process is taken off of the tree, it's kind of like chopping your finger off. you've got all the juice inside exposed to the elements, and that can start some of this chemistry to happen. We've not done extensive post-harvest studies and changes of chemistries. That's something we've talked about for a long time, and we've been trying to get enough material, and maybe we're getting close enough to the point where we can start doing some of these in very controlled settings and understanding what those sort of oxidative byproducts could be. All that to say that what's being done in the U.S. is in some ways very parallel to what's been done in Southeast Asia, in a large number of users, consumers of kratom products. Are in general doing it in a responsible way where they get the perceived benefit they're looking for, whether it's that mood elevation, endurance enhancement, pain relief. I think those are some of the main reasons that individuals report they use the leaf material for. And then you have the groups that are out there that are using it as a recreational substance to get a psychoactive effect from, and get high or use it as a replacement for opioids. There's a group of people that use it to get off of or transition away from prescription medications, but there's also a group of individuals that are using it to replace those medications because it's more easily accessible to them. They don't have to have a physician to write a prescription and go to the pharmacy. They can just buy the products, which then gets into the discussion about what products are really available in the United States. So we call it all kratom, but we've published a commentary a few years ago now that's not all kratom is equal. To me, it's the analogy of saying that you go into the liquor store, or the convenience store, and you call every liquor item in there booze, and you never differentiate between a beer, a wine, a spirit, or something like an Everclear, which is almost pure grain alcohol. And we differentiate that in that industry very, very nicely, and we have laws and products and classifications for all those products. In the kratom world, we don't have that at all, but we have that same diversity of products. And so you have something like ground leaf material, which is as close to the traditional use of Southeast Asia as you can get to. And then you start to move into extracted products. And then you start to move into very concentrated extracted products. And now we're seeing isolates and semi-synthetics or synthetic products being introduced into the marketplace. So we have that full spectrum of what I like to say seltzer or light beer, all the way to that pure grain alcohol, but we're calling it all one thing. And that makes it a very difficult thing to distinguish, and a difficult thing for physicians to understand as well, because if they start to treat somebody in an emergency department or even in their normal practice that says they're using kratom, the physicians don't know to ask what form of product are you using, right? I mean, they'll generally ask us if we're smoking cigarettes or we're smoking cigars or we're chewing tobacco, which type of tobacco consumption are you using? And all of those have a different risk profile associated with them. And the same is true for these kratom products in the United States. So as you increase the concentration of the alkaloids in a product or in a period of time that you can consume, you increase the risk of that product doing something that you didn't intend to happen to you. So it's to easily say that these things are risky. They're not without risk by any means, even in the most sort of what I would say benign, which isn't benign, but the most benign form, which is the pure leaf material, has the lowest amount of risk associated to it. But as you get to these highly concentrated extracts, which are more like energy shot bottles like that, you start getting into a situation where your body is exposed to the alkaloids at a much faster and more efficient way than if you were to drink a tea made with water or ingest leaf material with all the fibers that are present, all the sort of housing of the alkaloids, if you will. Your body has to work to extract those alkaloids, whereas in some liquid product that extraction process has already taken place, and this is a much more efficient deliverer of those compounds into our body. And then when we get into these synthetic or semi-synthetic compounds that have been introduced into the market most recently, you're getting into situations where you're almost taking a single pharmaceutical, again, without prescription, without medical supervision, most of the time without knowledge of a physician at all. And so you spend that entire risk profile, and there's a very diverse group of users, I think, in the United States, from what I described earlier, where there's many that are using it for that sort of daily benefit that helps them get up and get engaged in life again and gives them a lifeline, versus people that are using it on Friday night or Saturday night in combination with other substances and other things to sort of explore what kind of feelings or effects they can get from that. So it's a very it's a very diverse user population.
And to add to Chris's, products information, even if you think of leaves, fresh leaves, the varieties of kratom we have don't have the same chemistry. Some of them don't have mitragynine. They're very, very low amounts, but they're dominated by other compounds. They are still kratom, and people consume them because we got from one of the growers in Florida, but they don't have high mitragynine at all, and instead have high speciogynin. That can also influence what they experience after consuming those. And I don't know how many of the growers actually do chemistry on their plants, but there's quite significant differences in the chemistry between different varieties of kratom that we have.
Yeah, and I think just to expand a little bit more on that, we just recently completed analysis of over 350 products in the marketplace across all 50 states. And that analysis actually was very interesting because the mean alkaloid contents were pretty consistent. And what we were looking at was what you would think of as a typical profile for what you would expect in a Mitragynous speciosa product. That was the majority of the products, but we had outliers that were in that commercial set as well. Just like Dr. Nadakuduti said, there were some that had almost zero mitragynine in them, but still had other alkaloids associated that we knew would be present. And it could just come down to what's been harvested, what's been sold, what's been made. If it's growing locally, we do know that there's some local production and local sales of fresh leaf material in the United States now, which didn't really exist 10 years ago. It's more present now. There's some at least there was a commercial operation in Hawaii as well, selling locally there. I know there's some in Florida that sell locally in a very small area, but you know, we know that that product is a little bit different than the major product that's out there in the marketplace. And really the material that's coming in from Southeast Asia, there's tremendous variability on farms of the chemistries as well. We've done GPS tracking of trees or marking of trees that are right next to each other, that one tree could have very high levels of mitragynine, the other tree no mitragynine detectable. And so these, again, they're not paying attention to the chemistry. They're picking leaves, they're combining it, and then they're making a product, either this tea-like decoction, what they call juice actually, or they're just picking leaves off of the tree and chewing them as they're doing their work. And so they're titrating themselves. The market in the United States expects a certain profile of alkaloids, mitragynine, to be the most abundant, and so the producers and exporters in primarily Indonesia are targeting those alkaloid ranges. So they're trying to send a material that is high in mitragynine above everything else. And so they're sort of self-selecting what batches and harvests are going to come over to here. And I think that's why we're seeing a much more consistent marketplace overall. And then just to touch back on what we talked about earlier with the young leaves versus mature leaves, because we didn't kind of close that loop. But I mentioned we started to see speciosialatine coming up from being a minor alkaloid to now being the second most abundant alkaloid. And Dr. Nadakuduti pointed out that that is the most abundant alkaloid in the very young leaves. And so we think that what's happening now is supply versus demand. And the harvest is including much younger leaf material. And that younger leaf is getting incorporated into that sort of overall mass that's coming over, but they're still putting mature leaf because there's still number one alkaloid is mitragynine. But it's interesting because speciosiliatine is really the second most abundant alkaloid now, which if we historically look in the literature, it existed in less than 2% of the total alkaloid content.
Fascinating. So market pressures are perhaps encouraging harvest of younger leaves, and that's changing the overall alkaloid profile.
Yeah. And again, not the sensory perception, because we don't have that piece in the Western world.
Yeah. So my next question was going to be like, what is the overall safety profile? And it seems like you've spoken to that, and I just want to make sure that I've got the right idea, which is basically that the safety profile of crude products, you know, like chewed leaves or water extractions is pretty good, and people are often using it kind of in the way that coffee is used. You might have, you know, a heavier dose at the end of the day for a different effect. But now we're getting these more concentrated and even semi-synthetic products coming into the market in the US that maybe the safety profile is it's certainly different, and maybe something that's a little bit more to, you know, be careful with or be concerned about.
Yeah, I think, you know, from a safety standpoint, the safest thing is zero.
Always.
Always. But you know, from a safety standpoint, if we look at what is consumed in Southeast Asia in a more traditional sense, what we generally believe to be safe, but there's no highly controlled clinical trials that have demonstrated what is a safe, consistent dose, right? We have single dose safety data now, which we have for the first time through FDA trial that was really set out to look at a single ascending dose and how that dose was tolerated in individuals so that they could actually perform a human abuse potential study, which is multiple doses over a period of time and seeing what the effects are of those compounds. But in order to do that, you have to establish what are quote unquote safe and tolerated or well tolerated exposures. And based on that, we've come to the conclusion recently, and by the way, this paper's been accepted. It's just not in press yet with the FDA. And you can really see that about a 25 milligram of mitragynine dose seems to be relatively safe. I wouldn't say it is safe, but it seems to be relatively safe for consumption. A daily amount, we don't know what a safe daily amount is, but if it's safe to say that there's about 10 milligrams of mitragynine in a gram of leaf material. So we're talking about, in general, 2 to 3 grams of leaf material that seems to be well tolerated in humans that have taken that level. Almost all the clinical trials, which there's about 4 or 5, I think, that are either accepted in the literature or getting ready to publish, those doses have been fairly well tolerated. No changes in blood chemistries, no changes in mental status, no significant adverse events happened. The only adverse events that occurred were some nausea and vomiting in some of those individuals. So from that standpoint, we can say that it's definitely tolerated well and more than likely safe at that very, what we would call low level, 2 to 3 gram of leaf. The FDA trial escalated the dose all the way up to 12 grams of leaf in a single sitting, which is a sort of a monstrous dose if you're naive to it. Most individuals will claim that they use 2 to 5 grams per serving, 2 to 3 times a day. I've gotten emails from people though that are consuming 90 to 120 grams of leaf material.
Oh my God.
In a day. I mean, that's you definitely point to the fact that there's got to be tolerance that develops. Again, we don't have studies behind any of this to really show that. We do know that in animals, the tolerance develops much slower than it does to opioids, like pure opioids, but it does develop. And so people can become, accustomed to it, experienced with it, learn to tolerate more and more over time to try to get that same benefit that they were getting earlier. So it's really difficult to say where the safety line is. It's also really difficult to know because in most of the deaths that have been associated where kratom or mitragynine was found in someone's system, the vast majority, 95+% of those have been in combination with many other substances. And so it's very difficult to pinpoint and say this is a toxic level of kratom, a deadly level. But it would also be ridiculous to say that it can't possibly kill you by itself. I think.
Oh, I'm sure there's a lethal
Yeah,
dose somewhere.
anything is capable of lethality. So it's just something that we try to remember, but that's one of the main things we're really trying to understand from the human use perspective is where does the problem start to come into play? Where do we start to see adverse events that could be problematic? And in what populations, right? We have no idea, if you have an existing medical issue, how this could affect that. All these studies that have been published and done have been in either healthy animals or healthy humans, right? So we have no idea what this will do in someone that has some pre-existing condition, whatever that condition could be. So for safety, we really can't still say this is adequate or not. And just with the caveat that as I mentioned before, as we move from leaf material into these concentrated and synthetic, semi-synthetic compounds, the risk profile increases as you move up in that sort of product concentration class.
That makes a lot of sense. What about potential for addiction? Is that something that's been studied, or is that mostly anecdotal at this point?
So for sure, I mean, I find this fascinating because, and in fact, I even had lunch earlier today with my addiction physician buddy that we always talk about, well, what's happening in the lab and what's happening in the real world. And so pre-COVID, when we used to get together and have lunch, he would say, hey, people are starting to come in and are admitting they're using kratom to help reduce the amount of opioid they're using. And he said, and it looks like it's really working. It looks like it's helping some of these people a lot. And then, we didn't see each other for a couple of years. We didn't have our normal lunches because of COVID. And during the COVID time, we saw this sort of explosion in the marketplace of some of these extracts and concentrate products as well. And so when we came back together in like 2022 to have lunch, and he's like, man, now we're starting to see people coming in that want to get off of this and are struggling to get off of it. And so that's when we really started having the discussions around, well, what are they taking? What product are they using? We need to get a better understanding of what the abuse potential is. Here we are in 2026 now, about to have the first legitimate human abuse potential done, but it's going to be on leaf material and healthy human volunteers. Again, not going to be definitive by any means, but it'll at least give us a signal. I think though what we've seen is there's definite abuse potential. Again, could be product class related, may not be, may still be problematic for some people at the plain leaf product as well. There definitely seems to be an addiction component to it. There's for sure physical dependence that's created. That some people will certainly have headaches or agitation when they don't get their dose every day. Not too dissimilar from coffee for a lot of people, where if you don't have your coffee in the morning, you get a headache or you feel really more crabby and irritable. That's kind of the physical dependence that you initially see, I would say, with kratom products. But I've also had emails from individuals, again, that are taking these very high amounts, that say when they try to cut back, they start with restless legs. They're up all night. They have real difficulty trying to figure out how to get off of these high amounts of substance they're taking. And so I think there definitely becomes a point where addiction or dependency can be a problem. One thing that we researchers talked about many times in the past was we didn't see people breaking into smoke shops and stealing kratom leaf or kratom concentrate products, extract products. That all changed when the semi-synthetics came into the marketplace, and now we've seen gas stations being robbed at gunpoint or knife point for these 7-hydroxy products, and even other types of robberies taking place, and so it's in order to get money to get the materials. So these are more along the signs of addiction, where you're going to do something that you normally wouldn't do with your normal character, that pushes you into a drug seeking. You've got to get that drug no matter what it costs to get you that drug, you're going to get it. That's really the hallmark sign of addiction, not really that physical dependence. So there's a spectrum there as well. And again, not easy to define here. I think the key is, and what I've heard from most people is less kratom use is more. They get more benefit. They perceive more benefit when they use lower amounts. People that are trying to get some sort of psychoactive or euphoric feeling, that are pushing the limits to try to get those feelings, I think those are the ones that start to escalate quicker in those situations. And again, no scientific studies to back those statements up. It's just kind of the anecdotal things that we hear in talking to different folks.
That all makes a lot of sense and has lots of parallels with other plants like, coca leaf tea or chewed coca leaf is not associated with massive harms. And then as you step from that to powder and crack cocaine, there's a much different safety profile and problems that arise. Could you speak to any best practices that people should be aware of when using kratom to minimize potential harms? And it sounds like not mixing with alcohol and not mixing with other drugs is maybe like a baseline.
Yeah, I think certainly we don't know. So let me first say that we've talked a lot about all these different alkaloids, right, that are present in kratom. And so kratom by itself is polypharmacy. So you're getting lots of drugs in, or lots of molecules that are having a pharmacological effect within this one package of leaf, right? And so when I was in pharmacy school, trained pharmacist as well, they taught us that when you get 5 pharmaceuticals on board a patient, you can no longer predict what the drug interactions are going to be. And so I would consider kratom to be almost that 5 pharmaceuticals already before you add anything else. And so when people start adding other substances to it, or adding it to the use of other substances, which includes anything, right? Like blood pressure medications, any types of antidepressants or other centrally nervous system acting drugs, you increase the risk immediately of something happening. By itself, I think probably is the absolute safest. The lowest amount consumable is the absolute safest of the leaf material. I don't recommend people actually use it, but if they are going to use it, which I can't stop them from doing, I do say start low and start slow. See what your body can tolerate and where you start to perceive the benefit you're looking for. So if you're looking for pain relief or mood elevation or endurance, which are those sort of low dose stimulant type effects, then start with a very low amount and see if it improves what you're doing and how it works, and try not to get to a point where you're consuming a tremendous amount. If it's not working at 3 grams or so, where we feel that safe ranges, then maybe it's not going to work for you. I don't know. We don't have studies to say where the benefits truly start to come into play, and for what type of people. So those are the things I would say. Best practice is if you're starting with it at all, start with leaf. Don't go directly to the 5-hour energy looking shots. And that's the best way to do it. I know that some of the very early extracts and shots that came into the marketplace were like 3 times concentrate, or even just extract concentrate, not what we're seeing today, which is 10 times, 100 times concentrates of what you would normally get out of a leaf. And so individuals that have consumed leaf for a long time, many of them will use the liquid shots for breakthrough pain or those types of situations, but they're experienced and they know sort of how to titrate those things for themselves. You know, I don't ever feel comfortable saying any of it is safe, so to speak. But definitely, you know, the least amount of complications is if you take it alone and you take the leaf and you take a low amount of it.
Cool. That's great information. Um, do you think Kratom is likely to be federally scheduled in the foreseeable future?
Mm.
And
The
when I say scheduled, I mean
Yeah,
made
yeah, yeah.
illegal.
Yeah, no, you know, so this all started back in 2016, when the Drug Enforcement Agency originally announced its intention to place Mitragynous speciosa, mitragynine, and 7-hydroxymitragynine into Schedule 1 of the Controlled Substances Act, which means they have no medical purpose, and they're highly addictive. That didn't happen. That was the first time in the history that the DEA rescinded a decision or an intention, to schedule something. And to this day, it still hasn't happened, despite the fact that in July of 2025, the FDA and Department of Health and Human Services recommended to the DEA to schedule 7-hydroxymitragynine, primarily because of these semi-synthetic products that have been sort of taking over the market, and we know are pure opioid in their action, and just having access to pure opioids at a smoke shop or a gas station is, you know, in my pharmacy mind is basically like putting morphine for sale at the gas station. And it may be a beneficial compound. It may have been a beneficial drug molecule to pursue as a new pain reliever with less side effects. But unfortunately, that one probably will end up in Schedule 1, which will make studying it very difficult. It would put it in the same federal class as marijuana now. Of course, the states have all chosen how to regulate marijuana, in their own ways, whether medically and recreationally. And I don't know that we would see that happen for a single chemical like 7-hydroxymitragynine. It would need to go through pure FDA drug-like studies for approval in that way, and then it would have to be a prescription medication. The FDA was fairly clear in July that they said they weren't going after kratom leaf, and they wanted to fence that and protect that and make that accessible because it, in their opinion, is still an adulterated product. You know, they still don't say it's safe. They don't say it's something that they condone, but they also recognize that many people are using it, and many people are deriving some benefit from it in a more or less responsible way. I'm not speaking for the FDA by any means, but I think that they recognize that, you know, there was a call for science to be done in 2016. That's what really spawned our labs at the University of Florida to be able to get large grants to study all of this and start learning about the pharmacology and learning about where some of the safety and where some of the harm, starts to appear. But the one thing that has emerged from all of that is there's definitely medical potential. And how we go about exploring that fully is going to take a long time. I also think that the National Institute on Drug Abuse has a very vested interest, not only financially, but intellectually now in seeing how this plays out, because this could be not just a potential plant for opioid use disorders, but we're starting to see data emerge that shows it's working to reduce alcohol intake. It's working to reduce psychostimulant intake, so methamphetamine, cocaine. You know, we filed a patent way back in 2008, I think it was, where we said Mitragynous speciosa for all addictions, right? Shopping, sex, everything. And the U.S. Patent Office said not just no, but probably some explicit no. That it came back with more rejections from the U.S. Patent Office than our patent attorneys had ever seen at the University of Mississippi, where I was at the time. And so they said, just forget about it, guys. But it's interesting because as the science continues to emerge, we're starting to see that may end up being a reality, right? It may end up having this sort of polysubstance use disorder niche for potential therapy in the future. And God, there's a lot to unpack there and understand and figure out, what doses for what drugs for what, safety profiles, all these different things, all these studies that will have to be done. We're also seeing that in veterinary medicine, we're doing collaborative work with our vet school here at Florida. They're looking at companion dogs, so dogs with osteoarthritis, and they're looking at how is this helping with their quality of life. And the data is not published yet, but the preliminary data is pretty exciting. The dogs and the owners are seeing, some significant progress in terms of their quality of life improving. And so, there could be a analogous study done in humans to look at arthritic pain or long-term pain. And again, we're talking about low doses here. We're not talking about huge doses that cause problems. We did see the initial doses we started in dogs, they actually would become somewhat catatonic. We thought they were maybe hallucinating. Uh, they would they would just kind of freeze. They were totally there. You could, they would respond to you, but they were just like something's not right. So we ended up having to cut the dose quite a bit. So even lower than what we had initially thought. But it's working really interestingly in those studies. And so being able to do studies in animals is really, really helpful because you start to understand the, safety profile and how can we then take all of that information and project how it will behave in that population of humans. And so it's going to take a long time, Aaron, but we're getting there.
Yeah. Well, I'm glad that this science is in the hands of scientists who, by all indications to me, seem to be, have your heart in the right place and an open mind where you're not just looking at abuse potential or just looking at potential benefits. You're trying to see as much of the whole picture as you can.
Absolutely.
Um, when I was just kind of brushing up on some stuff before this interview, I took a look at the Wikipedia, and there's an interesting paragraph here about on August 13th, 2025, the Florida Attorney General announcing a emergency rule placing 7-hydroxymetragenine into Schedule 1. And that's a Florida specific thing, and I was curious if that had affected your work in any way.
Luckily, it hasn't affected our work. The intention. So first of all, we had worked with some of the Florida senators and the Florida Agricultural Department um, on talking about regulation of kratom products. So everything kratom. We never really talked to them about the semi-synthetic class of compounds because it really didn't it really wasn't emergent until 2024 when it started to become known and impacted in the marketplace, and really problematic, I would say. So it was interesting and a surprise to us that Florida actually came out and did this emergency scheduling after the DHHS asked the DEA to consider it at a federal level. Florida was out in front, which is what they like to do. and like to lead the nation in certain types of areas like this. And they never consulted any of us scientists, like what was the limits, what should they do? They just did it. A lot of people thought that we were behind it. At the University of Florida, if I had that power to enact legislation, that I would probably use it for other things like decreasing property taxes and doing things that are more beneficial to a lot more people. But uh, luckily it was done with the intention to remove products from commerce. It really wasn't done with the intention to impede research. Unfortunately, that's a secondary side effect that happens. Um, but keeping an open communication relationship with the state and officials, keeping inventory of things that we have. It's not federally illegal or banned yet, and that will create a bigger impact on our work for sure. But for right now, they're trying to figure out what are the ramifications of that going to be now. Because we study the pharmacology, we do have large amounts of highly purified 7-hydroxymitragynine, which set us up for, manufacturing, intent to distribute, all those types of charges that could be levied on us. I do have controlled substance license to be able to possess controlled substances. And so, once it is made a controlled substance at a federal level, we would include that on our Drug Enforcement Agency license and privileges. Right now, it's included. I included it on my Florida license, and so the state of Florida knows that I have written documentation that I'm allowed to possess 7-hydroxymitragynine for research purposes. So, it really hasn't impacted us yet.
That's good.
We're hopeful that doesn't change, but we'll just have to
Plants
wait.
don't have it, so I'm not impacted.
Well, we're coming to the end of the questions that I have. If there's any other information that I should have asked about that you'd like to share, I just want to give you the opportunity to throw out any other informational tidbits you might have.
So with respect to, plant growth, cultivation in Florida, these are the things that I think about. Sometimes, as an example, I was talking to a gentleman who consumes kratom, fresh leaves, but then we analyzed the chemistry of that, and I told him this doesn't have mitragynine, but he's like, I don't care. It gives me what he's already positively experiencing, some effects that help him. And so I see that, some of the Florida, growers, they may have varieties that have different chemistry. And so, there is some difference there in terms of, toxicity of each molecule can be different, right, Chris? Like in terms of, when you ingest certain material. So somewhat, but when they analyze the products coming from, as a packaged products, they're pretty consistent coming from Southeast Asia. But what we have in Florida may not be as consistent is my worry. And people may be experiencing different, experiencing different effects because of consumption of varieties of kratom.
Yeah, and I think just to follow on that, it's also interesting from the standpoint that what we talked about earlier, where mitragynine has always been thought to be the major player in terms of the activities, and the fact that it doesn't exist in some of these plants that are growing, but the other alkaloids do,
Right.
and people are reporting they're getting some of the same benefits that they got when they used dried leaf from Southeast Asia. It sort of makes us rethink the whole pharmacological approach that, can we design a cocktail of alkaloids, and that's kind of what we're working on now in our laboratories, is actually taking the purified alkaloids from the plant and putting them in the ratios that they exist in the plant and giving them to the animals in a more, pharmaceutical grade form, if you will. And then being able to play around with that, like I was talking about that sort of mixing board, right? Let's change the ratios up. Let's take mitragynine completely out and see what happens, or let's reproduce the alkaloid ratios that we see in some of these fresh plants growing in Florida, and what pharmacologies do we see in animals that are similar or different, and what toxicologies do we see that are similar or different. I think all of these lead to just more questions. We know with cannabis, varying amounts of THC and CBD, and now some of the other compounds like CBN and CBG, and all of these different cannabinoids at different levels seem to cause different effects. And maybe we see the same thing with Mitragynna speciosa or variations of Mitragynna speciosa. And so, I think it's from a research perspective, you said it earlier, we have a lifetime of work to do.
Yeah.
It amazes me. And again, we're only talking about alkaloids here. So there's all kinds of other chemical classes that are present that could be contributing to a lot of these effects too.
Well, this has been a fascinating interview. I really appreciate both of you giving your time to talk to me and share your deep wealth of knowledge. If listeners want to follow your work, where might they look to keep up with your research?
Yeah, so we're faculty members at the University of Florida. So our profiles are public on the University of Florida's website. That also includes our emails. That's where I'm sure many people find me and email me their stories. And I don't provide advice. I'm not a physician, so I don't give medical advice. But I'm always intrigued to hear what people's experiences and stories are, because that actually gives us ideas on what kind of research we may pursue or what directions we may go. And so I always welcome, sometimes I probably shouldn't say it out loud, but I always welcome emails to hear those stories.
Yeah.
Some are quite entertaining, but we can be followed there. I think one other key aspect that I, I think is really important and really groundbreaking for Dr. Nadakuduti and the work that she's been able to do. She was the very first person funded by the United States Department of Agriculture to work on Kratom in a very large grant for agricultural world, to do the work that she's been doing, and in collaboration with us. We're kind of the minor backup band for her and her work, just like we play very well together in those species, in that space. But I just want to really acknowledge the tremendous contributions she's made and her team's made to this, because the plant is really what this is all about, at the end of the day, and working with people that are truly passionate about understanding the plant makes it so much easier for us to do our work, to really understand, how things are working. And so it's just a unique place at the University of Florida, where we get to have agricultural program and a full complement of healthcare programs at the same university. It's a very rare thing. So we could literally go from her growing Mitragynna speciosa from seed all the way through clinical trials right here, without leaving campus. So it's pretty cool.
Yeah, without analytical chemistry, I mean, plants we grow, but without that, it's hard. So, it's not a small contribution, but, pharmacy group is significant contribution to our work. And it's a beautiful, collaboration, because we learned quite a lot in the last few years that I started working at UF. And, certainly I don't get as many emails as Chris does, obviously, but some people have contacted regarding cultivation or some problems they may have in the plants and so on. I do try to help as much as I could. We figured out how to grow plants, good plants in greenhouses, in our greenhouses at UF in Gainesville. We also figured out how to propagate in tissue culture, which we're having a bunch of plants in tissue culture now. And so we've learned quite a lot in the last 5 years of Kratom research. And all our publications also I made available on my lab website. For anybody who want to read them, I uploaded them so that they have access to it.
Awesome. Yeah, because sometimes academic articles can be
Yeah, if they're not
paywalled
open
and
access,
yeah,
yes,
difficult
yes.
to get to. So I will certainly be linking to that in the show notes so that people can find it easily.
Absolutely.
And again, thank you so much for both of your excellent work and taking the time to talk to me today.
Yeah, thanks for having us
Thank you.
on. It was fun.
Absolutely.
Thanks.
So, very